Hey, what is this photo?
You seem to like photos from old times.
Yeah. So looks like, this is 0 and this is 90 or 10, 20, 30. You know? Looks like.
Yeah, has to be.
Some degrees are marked.
Yeah.
It's not that readable from the photo.
It's like something from a clock that is kind of moving back and forth.
Okay. So
because there's
you see a pendulum here.
Exactly.
Something which is free to move in
right.
this direction or this direction.
Yes. So in clocks, you see this kind of thing. That's what it looks like.
That keeps oscillating.
Keeps oscillating, right?
Yeah. Back these days, we don't see such clocks. Huh?
No.
Yeah. Oh, this is not definitely clock.
Yeah, but also this has degrees, right? 10, 20.
Yeah.
So
I have another hint. So this one looks like a simplified cross-section of a ship.
Yes.
And this photo is actually from inside a ship.
Is it?
Yeah.
Oh, that's interesting. So in that case, if you talk about ships, ships kind of out in the sea.
Yeah. So
sway.
Correct. So there may be some inclination.
Some angle
With respect to the gravity vector.
Correct.
As you said, because this guy is free to move.
Yes.
When the ship, when there is an inclination, this will still be aligned to gravity vector.
So what's going to move then?
The background will move.
Oh.
So this structure.
So there are two parts again.
Yeah, this structure is fitted to the wall. So when the ship moves,
that will move.
That will move along with the ship. But this one, this element is free to hang like this.
Right.
So it will continue to be like that.
Right. That's just
so basically it will be what is the angle of inclination.
So this is also kind of like a fixed member and a movable member.
Yeah.
Correct. Different way of.
Correct. So this one is fixed, while this one is movable.
Well, that's very smart.
Yeah. I think. And this has been people are using, right? Yeah. But now let's say you want this information electronically. I want to record somewhere, or I want to use it to control something. Ship may have fins. I can adjust the fin angle to stabilize
some automation.
Yeah. But I need this information electronically. From this
is visual, right?
Visual.
Yeah. What are you getting at, Bobby?
So can we see, now we know resistive sensors, wiper, things like that. Can we somehow use that to realize this and get an electronic output or electrical output?
If my mind was running wild, I would say put a camera and see.
That's also correct.
But I'm sure there are better options.
Yeah.
And I feel that we are kind of coming to a.
Of course, you can put a camera for this, and then find out the angle between these two.
Exactly.
Using image processing. Right. That's a nice solution.
But it also, to me, sounds like a complex solution.
Maybe unnecessarily complex.
That's expensive.
Yeah.
I think camera.
Yes. Because I just need the angle of inclination.
That's all you need.
So I need to still keep this and the camera. Watch this.
Yeah.
Of course, we can optimize that still.
Yeah. But
from what we know already, is there a...
Yeah. From what we know, well,
somehow this has to serve as a wiper.
Yes. Especially because you talked about
angular one,
right?
Yeah.
So then,
what will be the wiper?
That's a good question. But one has to stay stationary. No?
Correct.
The other one has to move.
Yeah.
And it has to be electronic.
Yeah. And the wiper has to align to the gravity vector, to nothing else. Maybe I have a drawing. So of course, its name is inclinometer.
Inclinometer.
You are measuring the inclination
Yeah.
with respect to the gravity vector.
Oh,
So it's a slightly modified version of yesterday's diagram.
It is. Okay. I can see what you're getting at.
Yeah. So this is a resistive element. This drawing is not proper, but it's a resistive element.
Yep.
And then there is another conductive shape that is kept surrounding it. I will erase this, right? Let's say, suppose we connect this to plus, okay, I'll use plus VR, a DC voltage.
Okay.
And this we will connect to a minus VR.
Okay.
So basically, this is at now. Sorry. So this is 360 degree. So let's say this point is at plus VR and this point is at minus VR.
Right.
So that means here it will be at 0 volt.
Okay.
Right? Correct?
Yep.
Now you see some interesting unit here. It's a small sphere.
Small sphere.
Yeah.
Conducting.
Yeah, conducting.
Okay. What is it?
So that actually makes the contact between the resistive element and the outer ring.
Okay.
So if I say, okay, there is 0 volt here, the outer ring will be at 0 volt.
Oh.
So I can, take a connection from here, maybe measure that voltage using a voltmeter. For
when it touches.
Yeah.
So I believe in that case, somehow this ball also has to stay in the same place though.
Yeah. Because
right?
The ball is free to move.
Ball is free to move.
The ball is just left here.
Yes.
Of course, with the casing, so that it will not come out.
Yes.
The ball is always in contact with the resistive element and the conductor.
How to conduct?
So in this situation, you are given plus VR, minus VR. So it's at the center. The outer one is at 0 volt.
Yes.
Now let's say the this outer structure tilted by some angle. If it is tilted by some angle, this structure will rotate.
Yes, the whole structure will rotate.
Whole structure, ball will be still here.
Yes. It will move a little bit, but eventually it will come.
Yes. Right? Finally, it will come to that point.
Right.
So for now, let's say the structure, I cannot rotate the structure. So let's say the ball is somewhere here.
Yeah.
That means the corresponding voltage I will get here. That will be measured by this.
Right.
So essentially, it's the same potentiometer or resistive sensor that we discussed. It's just that wiper is removed by, replaced by a ball.
And that's your gravity element.
That's the gravity element. I think I have a better picture later. Yeah, like this. These two are used for supplying the voltage.
Yes.
This is used for the measurement.
Correct.
And the ball is here. So now if let's say, if there is a tilt, the outer structure rotates, but the ball still rotates.
Right. But then your resistance will change.
Resistance, or now this voltage is dropped uniformly here. No?
Yes.
So it was 0 here.
Yes.
It will be some other voltage here.
Right.
Because that voltage will be reflected here. So now my voltmeter will read something because we have given plus VR this side.
Minus.
Yeah. So the voltmeter will show some positive voltage here.
With respect to the movement.
Angle
movement.
Yeah. Yeah. So the voltage that you are applying here, VR, you can select in a way that it corresponds to the angle somehow.
Right. And it can go 360 degrees.
Yeah. So suppose if you give 1.8 volt, then the whole 180 degree is reflected in that. I mean, 1.8 volt is dropped across 180 degree.
Right.
So each degree you will get a corresponding.
But then you can have readout electronics.
Yes.
Someone who reads from the outside will only see the angle.
Yeah. So that voltage corresponding to that is directly available here. So instead of a voltmeter, I can give it to a recording instrument, a computer-based recording instrument, save that data, or use that data for some feedback applications that we will discuss later.
Right. So this is for a constant inclination.
Yeah, there is an inclination, and it's
a ship, then it's moving like this now.
Yeah, it will be keep moving.
But generally, ships, keep you, but maybe not so much.
There will be a little bit of inclination. So, I mean, it could be the other way also, the other diagram, minus theta. But the point you made is, there is some friction between this ball and these structures.
Yes.
So when the outer structure moves, ball also will
move a
little bit, and then finally,
because of gravity.
Yeah. So it will be. I mean, suppose if it is like this, then it will be something like this. It's oscillate. Sorry, and
then come back.
Yeah.
I guess it also depends on how quickly, your ship. For example, if you talk about a ship, how quickly it moves, right?
Yeah.
If it moves only a little bit, then this ball might not move so much. But if it it's a sudden movement.
Correct.
Right? It might move more.
Correct. For a ship, what you're saying. But for some other application, the tilt may be quick.
Yes.
At that time, what we are seeing is it takes some time to settle.
Yes.
Correct? Takes some time to settle.
What does that mean, though?
So there is a settling time.
Yes. So that means there must be some fluctuation.
Yeah.
Because you're measuring down the voltage.
Correct. So what we are seeing is, I mean, let's say this is the final output I have for an angle theta. But with respect to time, it may be settling like this. So the reading in between is not very accurate, right? Only the final reading is accurate. So you need to decide based on your application, what is the rate at which you wanted to take the measurement.
How many seconds, for example?
Yeah. Because if you are using this sensor output for some feedback control,
like real time,
then it might then these oscillations will be a problem. Yes. So it depends on the application.
Yes. So the frequency of what you're trying to measure is important.
Yes.
Right.
Like yesterday we mentioned about the bandwidth of the resistive potentiometer.
Yes.
The linear sensor is only 3 hertz or so.
Which is
right. Correct. Yeah. I have a question. Now, let's say this is made here and then I have certain settling time and so on. I take this to, let's say, moon. Right?
Might just play with gravity now.
Yeah. So, will the settling time be same?
I think we have enough problems on Earth.
Yeah. Because of course the mass is different.
Yeah. So your question is, so if you take it to the moon,
the settling time, will it be same as that we see here in Earth, or will it be more or less?
There's no gravity. There's no gravity.
Yeah, it is. I think 1/6.
1/6.
Correct.
I mean, very small.
Correct.
Correct.
So
that's a good question.
Yeah.
I mean, if you think about spaceships, I'm sure they have interrometers, right?
Yeah.
Maybe different type, but still,
correct.
It's a good question.
Yeah.
To think about.
That's for them to think.
Yeah.
Yeah. So what we see is this has got various applications.
Yeah. But I mean, a simple principle, right?
Yeah.
So many applications.
Correct.
Applications that you probably wouldn't think.
Yes.
That these types of
this are just two samples.
Yeah.